An example river valley in the UK is the Calder Valley in the north of England. The River Calder's source is on Heald Moor, on the border of Yorkshire and Lancashire, and it eventually flows out into the North Sea. In its lower course, the Calder joins the River Aire, which then joins the River Ouse, finally flowing through the Humber estuary. If you haven't had the chance, do watch the upper, middle and lower course videos available on this channel. This is the long profile of the River Calder, showing the changing gradient of the river from its source to its mouth. A long profile is usually concave, and the slope becomes more gentle towards the mouth of the river. The dotted line on the right will continue for over 100 kilometres more as an almost flat line until the river reaches the sea. If we follow a river from its source to its mouth, we see changes in the shape of the valley and channel. This is best shown using cross profiles. Imagine if we were able to cut down through the river valley in the upper course. We would see a cross profile like this. In the upper course, vertical erosion takes place, and the river erodes downwards. There is little lateral erosion. As a result, we have a V-shaped valley with steep sides. The channel is narrow and shallow. In the middle course, the valley has widened. Vertical erosion is decreasing in importance. More lateral erosion and deposition is taking place, and the cross profile reflects this. The river channel is now wider and deeper. In the lower course, the valley sides are very wide apart. Sometimes it can be difficult to spot the sides of the valley, they are so distant. The river channel is now at its deepest and widest. When all three cross profiles are shown together, it is possible to see the differences in their shape and character. But do be aware that the scale of each cross profile is likely to be different. In a river's upper course, we can see landforms resulting from erosion. For example, it is in this section of the river that we can observe interlocking spurs, a series of ridges projecting out on alternate sides of a valley around which a river winds its course. If there are areas of hard rock which are harder to erode, the river will bend around it. The river isn't powerful enough to cut through the spurs and so has to flow around them. In the upper course we also see waterfalls. Layers of harder rocks erode less quickly. Softer rock below may erode faster. A plunge pool may form below the harder rock, undercutting it until it collapses. The waterfall will slowly retreat, leaving another river feature, a gorge. In the middle course we see landforms resulting from both erosion and deposition. Meanders can crop up anywhere along the course of a river, but they are always much more frequent, larger and more curvy in the lower reaches. In a straight river channel, pools and riffles will develop as water twists and turns around obstructions, such as large boulders. This results in areas of slower and faster water movement. Pools are areas of deep water and greater erosion energy due to less friction. Riffles are areas of shallow water created by deposition of coarse sediment. Once pools and riffles have developed, the river flows from side to side in a winding course. This simple model shows how the corkscrew-like flow of water moves material from the outside of one meander and deposits it on the inside of the next bend. Water moving faster has more energy to erode. This occurs on the outside of the bend and forms a river cliff. Water moving more slowly has less energy to transport material, and it deposits some of it on the inside bend. Water moves slowly on the inside of the bend, and the river deposits some load, forming a gently sloping river beach, called a slip-off slope. The thalweg is an imaginary line that connects the lowest points in a river channel, and thus is the line of the fastest flow or deepest water. River meanders are constantly changing their position. At this particular spot where we have a looping meander, it is possible to project what is going to happen next. Maximum erosion is on the outside of the bends where the water is running fastest, and it will extend the loop of the meander. Continual erosion and deposition will narrow the neck of the meander. At some point, probably during a flood, the river will cut through the neck. If that happens, the river will then continue on its straighter path, and the meander will be abandoned. New deposition seals off the ends, and the cut-off becomes an oxbow lake that will eventually dry up. In the lower course we see landforms resulting from deposition. The river now has a wide floodplain. A floodplain is the area around a river that is covered in times of flood. The floodplain is a very fertile area due to the rich alluvium deposited by floodwaters. When in low flow, deposition raises the riverbed. As a result, the channel cannot carry as much water. During flooding, water flows over the sides of the channel, depositing more silt or alluvium on the land alongside the river. A build-up of alluvium on the banks of a river can create levees, which raise the river bank. As the velocity of the floodwaters decreases, coarser material is left first on the banks, followed by finer sand and silt, building the height of the levee. As it nears the sea, the river becomes tidal, meaning that twice a day the flow of the river is interrupted as water sweeps up the river valley from the sea. An estuary is where the river meets the sea. They are affected by tides, wave action, and river processes. As tides rise, rivers can't flow into the sea, so velocity falls and sediment is deposited, forming mudflats. These may develop into salt marshes where the right circumstances prevail. Check out the other revision videos available on the Geography Juice channel. Good luck in your studies. Thank you for watching.